So yeah, I'm just going to be talking a little bit about kind of practical performance tuning that we've done. This isn't particularly a case study in the way that the other case studies in this room are, but it is kind of, it's a kind of more global case study into different setups that I've seen and stuff that I've worked on, and just some different techniques for helping scale out Puppet, since traditionally I think people have been concerned about the scalability of Puppet, and so this is kind of an answer to that because I'm tired of hearing it. So here we go. So yeah, I'm an engineer at Red Hat. I work on Foreman, which is a provisioning and ENC and reporting tool that's kind of pretty big in the Puppet world. I also work on some other stuff. I work on Fedora and RubyGems and Bundler. And yeah, before this, I worked at Venmo and Acquia and a website called Dig. So I'm going to cover a kind of a large swath of things, and it's going to be less focused on kind of performance tuning your actual Puppet code and more focused on the infrastructure that runs it. So primarily, I'm going to be talking about mastered versus masterless deployment and kind of the advantages of each. CA management a little bit, clustering, node management, and then development and deployment practices. Just touch on that at the end because I think it's a pretty important piece of the story of scaling out Puppet. So this is going to be less about the kind of specifics of scaling a single piece of infrastructure and more about actually getting Puppet to work at large scale. So I think before we actually cover how we're going to do this, we need to cover why we're using Puppet and why we're kind of growing with Puppet. And I think there are a few different motivations for this. So the first one is hyperscale computing, which is primarily focused on ARM, but there are other variations. And one of the really kind of critical reasons that we need to care about this with ARM, for example, is because we're going to have racks that have 4,000 servers in a single rack really soon. So these ultra-dense servers, we're going to have so many more of them that things that used to be easy, managing a rack of servers with Puppet isn't hard right now, but managing a rack of 4,000 servers with Puppet is going to be a lot more challenging. And so that's kind of a new thing that's coming down the pipe that we have to kind of keep an eye on and make sure that we're able to scale to that level, especially because if you have an entire data center filled with ARM, it's going to have some pretty substantial challenges in terms of the kinds of management tools that you can build atop it. Another thing is we're just building more infrastructure, right? There's so much more stuff going on, and the internet's growing, obviously, and so we need to kind of care about the infrastructure as we grow it. And people are having these multi-data center with failover and sharing between the public cloud and private cloud. And we have, with the cloud, this whole new environment where people are spinning up instances that are super short-lived, which invites a whole new set of challenges on top of things that we already had. So stuff like, how do we efficiently sign certs when we're about to bring lots of hosts online? So this is kind of an endless debate in the Puppet community, and I'm actually not really sure where I stand on it. But a lot of people who run it at very large scale don't use masters, and that's because the master is kind of the one thing that every agent then has to go and talk to. And by avoiding a master, you get the ability to just, you roll out to whatever you need. You roll out, updated code to whichever boxes you need, apply it, and it just go from there. And so instead of having this master that all the agents call to, you just apply Puppet on the host that you need. And that makes it much easier to kind of do scaled rollout, slowly push stuff out and test it. And you can obviously use Puppet environments for that, but this is kind of a new way, or I shouldn't say it's new, it's been around for a while, but it's kind of, people are rethinking how to do applies, and I think mcollective is actually a pretty big part of that. So what it looks like to provision a node with the master is you basically bring the node up, install Puppet on it, a script runs to install the packages and point at the Puppet master, the agent runs, generates a signing request, sends it to the master, and then you sign the cert on the master. And obviously you've probably automated this. But without a master, all you do is you bring the node online, a script runs to download a package or a tarball, and then you just Puppet apply. One of the interesting things about running Puppet without a master is that all your nodes need to know their role before you're going to Puppet apply, unless you kind of build an external service. So your database master needs to know that it should have Postgres on it, and it should have bindings and whatever else it needs. And so it needs to actually know its role before you apply. Another critical part of the Puppet infrastructure that we're building today with masters is managing the certificate authority. So this is the only truly stateless, this is the only truly stateful part of Puppet. And you can build scaled out master clusters without having to deal with the fact that you have to manage a CA by moving them to their own pairs, essentially, or larger than that. So running the CA on its own cluster, and then having lots of stateless masters that you can bring up and down as you need them. For example, if you're not running the agent as a daemon, then this is much less of an issue because the agent, obviously, if you're running it only when you need to, so I just pushed a change and it affects these hosts, and then you run Puppet there, you need a lot fewer masters than you would otherwise. And so a big part of being able to scale up masters and scale down masters is just the fact that if you don't need as many, you can just bring them down. And so having stateless masters are obviously just like a stateless app machine or a stateless API machine. There's obvious benefit to this. One important thing that sometimes people miss and hurt themselves in doing so is that the certificate revocation list needs to be shared between all the masters. And so the way a lot of people are doing this are with tools like Ceph and Gluster, or even just NFS, to share that across all of the different hosts. And without that, you lose a big part of what comes with Puppet CA. So obviously, if you can't revoke certs and something happens and a cert gets leaked, people now have access to your infrastructure. That's probably not awesome. So as I said, the CA has a lot of state, and the masters themselves, the ones that take requests, should be stateless. And another big part of this is to reduce the file shares that you have to do. Obviously, NFS, when it fails in really fun ways, and the load on your machines go crazy. It just goes through the roof. And so reducing the number of file shares that you're doing is great. Just make sure that the CRL is where it needs to be. Otherwise, you're in security problems. And if you have security people, they'll be really upset with you. So one of the things that a lot of people are doing now is DNS-based clustering. And what this essentially means is you have a bunch of masters and a single CA behind a round-robin DNS record. And this is really nice because it means that you don't have to manage a load balancer in front of it, but it does have the disadvantage of propagation. So if you need to take something, or if you want to add a new master into rotation very quickly, it's much more difficult to do it if you're managing it on the DNS level. Although, one of the really nice things is that obviously you can set low TTLs, and so that almost makes up for it. You can set a 10-second TTL, and it's not a problem, really. But here again, you want to have one CA, and by delegating the CA away from the Puppet masters, you get that same benefit of, oh, that master that's running on AWS just fell over. Let's just bring up a new one. Another pattern that also works fairly well is just using the load balancer in front of a bunch of masters. So you probably have two HA proxies or Nginxes or Apaches running mod proxy. And behind them live a bunch of Puppet masters. And with this tooling, you can basically do stuff like health checking behind the load balancers. So if one of them falls offline, it's not an issue, and your agents continue to run. Again, notice the split out CA. In a more complex deployment, you would obviously have two load balancers that are DNS round robin in the front because you want active passive load balancing. Otherwise, bad things happen again. So masters across data centers tend to be tumultuous, especially if you don't have network interconnects between the data centers. So if you have data centers that are kind of connected to the public internet and you don't have VPN between them or just fiber or something, the conversation that has to happen is whether you want to use a shared CA for all of your hosts or per region CAs. So a pretty common pattern that I've been seeing recently is people spin up a CA in each data center or region and then talk to that one based on that master. It does have the disadvantage of if you have a security incident, you still end up in a position where you have to manually go to each data center, unless you, obviously the security incident is localized, but you have to go to each data center and clean the certs up. So another kind of critical thing when you're working with multiple data centers is to be able to control where rollout's going. And I'll talk a little bit more about this when I talk about deployment. But I think it's really important that people have real deployment systems for their Puppet code. It's going to affect production, and you should have real deployment tools set up, just like you would for production. So deploying in stages across data centers helps prevent kind of very, very bad failures that cause multi-DC outages, which I've seen before and are bad. And so I think one of the things that you need if you're going to go multi-DC is to kind of decide on an architecture early that prevents failure. Obviously, there's then the multi-cluster layout, which is obviously, it's also very complex. And you might want to run one of these in each data center, depending on how many machines you have. But potentially, you have one for the kind of global infrastructure that you have. You need to make that decision based on network topology and other things that would decide how fast the network is between data centers. But the shared CA is still there. So the option to have a local CA or a shared CA between a multi-cluster environment is pretty clear, in that you should have a single CA, in my opinion, especially if you're running this within a single region. So that's kind of the end of the section about clustering masters and CA management. But next is node classification. So traditionally, people have done this, and it's a little odd and janky, and it works well if you have small infrastructure, but it fails really quickly. And for those of you who don't know, this is just what a node manifest would look like. And all you're doing here is matching based on cert name. And so you say I have a base node, and then I want to apply all these things for individual types of nodes. So app.example.com gets one thing, and my Redis servers get another thing. And it's all based on host name. This obviously is the disadvantage of when you move between roles. So if you want to take a database master, and you may not do this depending on your infrastructure, if you have solid Pixie infrastructure to re-provision machines, you can just take a machine, reinstall it, and then run Puppet on it again with its new cert name. But obviously, it's challenging still to have host names be the classifier. So in order to really take infrastructure from smaller scale where you can do this kind of thing to kind of more higher extremes, you want to be able to classify nodes based on other data. So this is where external node classifiers come in, which are a critical part of being able to spin up lots of nodes and practically manage them. So for those of you who aren't familiar with ENCs, all they are really is a data source that lives outside of your kind of Puppet infrastructure, and the Puppet master, when the agent calls home, goes and gets data from that data source. So it basically hits a URL and gets some YAML back. Puppet Enterprise, the Puppet dashboard, and Foreman are all good examples of ENCs. And what they let you do is kind of manage stuff externally. So if you have your own CMDB, for example, you have people in your data center who are typing in MAC addresses into some system, and you want to get data out of there and then feed it into Puppet. So say you want to add params to classes based on data that you store externally. ENCs are the way to do that. And it's as I said, it's just your own data source. And obviously, it's a key integration point if you have an external CMDB. The most popular ones are great because they have communities around them and lots of users, and they've solved a lot of issues. So Foreman, for example, and Puppet Enterprise as well, have also solved the provisioning side of things fairly well. And so by being able to provision nodes and then classify them during the provisioning step as opposed to after, you get a lot of benefit there as well. And I think one of the things that we're not doing all that well with custom ENCs yet is being able to do integrations with any of the existing ones. So if you want to get data back out of that CMDB and feed it through, say, Foreman, that's a little challenging right now. And on the Foreman side, we're getting better, and I know Puppet Enterprise and the dashboard are also working on that. So being able to say, yeah, I want to go out and talk to this vendor, feed that data back into the ENC kind of asynchronously, and then run Puppet. This is what Foreman looks like, just a little plug. This is editing a host group, so you can put hosts into groups. Puppet Enterprise has the same thing, as does the dashboard. And so you can basically say, all my hosts that are of the builder type look like this and have these classes installed on them. In this case, they're all grabbed off the disk. So in Foreman, we go out and talk to smart proxies and then feed data, which are just little agents that run on each Puppet master, and then we feed that data back through to be able to grab all the available classes. So on the masterless side, I wrote this little GitHub repo that uses librarian and FPM to build RPMs or debs from a librarian file or just static modules. It's very young, and it's a bash script that's like 12 lines long, so feel free to rip it off. It's GPL'd. And what this actually does is it provides a similar deployment solution to be able to build individual packages based on the type of machine that you're running. So, for example, you can say, build me a package for my database masters, and then it just actually calls librarian and runs. One of the advantages of packaging, actually, for masterless is that you can put all that stuff in a repo and then have versions of it. Obviously, you could do that with tarballs, too, by just dropping them onto a file server, but the native OS integration is beneficial. So one of the last steps is kind of distributed runs. One of the things that people run into really often is when running Puppet every half hour, it's a pretty tumultuous process at really large scale because of the fact that you're obviously just slamming your masters, especially if you have hundreds of thousands or millions of machines. Masters that have runs that take place really often is technically, it's a pretty bad thing when it goes on. And so a lot of people quickly move away from running Puppet as a daemon to either crons or just running Puppet when they need to. So you can say, I know I just had this change that affected all of my app servers, or I know I just had this change that affected all of my machines that run Debian, and then you can go out and use something like mcollective to say, give me back all the machines that run Debian. All right, now I have that list. Go and run Puppet on them. You can actually do it in one step with mcollective. So that's a really powerful tool. So all you need to do in that case is run Puppet when the code changes, and that prevents having to call home as often as you would before. But obviously, you can also just move away from running Puppet as a service that runs every 30 minutes and switch to it every day. So for example, you could have it run every night at midnight between midnight and 1 a.m. on all your infrastructure. And then if you make changes during the day that require Puppet runs, you just go in and use mcollective to do those runs. So as I said, I think one of the things that people kind of fail at scale is deployment. And despite the fact that we've done a really good job as a kind of operations community at figuring out ways to get code out into production quickly, we've done a much worse job at figuring out how to kind of get config management code out effectively. And I think a big part of that is canary building. And I've seen a lot of infrastructure that does this, but it's hard to do well, especially if you have a shared Puppet master infrastructure and not a lot of environments. So the issue with deploying Puppet code in a kind of way that isn't reproducible is it's hard to roll back. And if you're doing canary runs, then obviously you need to be able to roll back. And so just like you would with any other system that say you're using Capistrano, just like you would with any other system that requires deployments and roll out and roll back, you need to be able to quickly be able to kind of take your code, deploy it, and in this case, you can deploy it to a single data center. So say I want to deploy only to this data center based on its host name. You can do this fairly easily. This code, to let you do this with Capistrano and Cap Multistage, will be on GitHub tonight, so I'll put it up. But all it does is does a regular cap deploy without any of the Rails stuff, and then symlinks the modules and manifest directory. So yeah, controlled releases are critical. And another thing that you can do that will help you get your infrastructure more solid as it kind of grows up is to run Puppet in Nagios passive checks. So I really like this pattern. Some people don't. I want to know when my Puppet runs fail. And I think running Puppet via passive check is a pretty cool way to be able to see if how hosts are doing and monitor host health over time. And this way you can also kind of set up checks that run on a certain period as well, just like you would with a cron job that you set up every night or something. So that's all I've got. There's a mic if people want to ask questions. We have about 10 or 15 minutes for questions. So.
I've seen a lot of people talk about some of the disadvantages of M-collective, especially when they get past like 4,000 or so nodes. Mm-hmm. And I see where some people are just automating SSH runs to kick their puppets.
Yep.
Internally at FedEx, we have a couple of different frameworks for doing stuff like that. But outside of our own ecosystem, we see where people use PSSH, DSH, all sorts of different wrappers, and et cetera. Do you see any kind of like SSH-based framework coming into place or developing or in its infancy anywhere that maybe people should be looking at?
So I think, there's PSSH. There are a bunch of distributed SSH systems. One of the cool things about having an ENC is that you can query the ENC for all of the reports that it's got, and like say all the hosts that have that look like something. So all the hosts that have 8 gigs of RAM and whatever else, get a list of those back. They all have APIs, and then run Puppet via SSH on those hosts. A lot of those tools do fall over at scale, but you can basically page out if you want to be able to say, do the first 100, second 100, so on. But I haven't. I mean, I don't know of anyone who's working on distributed SSH.
I mean,
still.
everyone can do XOR minus capital P with a list of, say, everything that matches Oracle from their ENC or everything that matches Apache. I mean, we all know how to do it, but it doesn't seem like anyone's really put together a framework that maybe tracks tokens or status in a good way yet, right? Yeah,
that could definitely be an interesting thing. It would, it's funny how we've kind of gone from the world of we hate SSH to like, oh, we need SSH to apply this thing because we can't consistently apply it.
Kicking puppets ain't easy, man.
Yeah.
So a bunch of your first section there was about scaling Puppet masters, but having this problem of needing to limit the CA.
Yeah.
And a lot of those solutions are very effective, but if you want to work around those, it is actually possible and will continue to be possible to do some stuff with certificate chaining, so that actually any master can sign a certificate, and any other master will recognize it.
Yeah.
So that's another option to get yourself the scalability there without even a CA, single point of failure.
Definitely. I've had, I think it was buggy in the early days, and I had some really sketchy experiences with it, so I'm afraid of it. But in Puppet 3, they also have really solid support for using an external CA, so if you have a corporate CA, that's another option.
Yeah. In 3.2, the signing works fine, and there's some regression tests in place to make sure it stays working.
Cool. Any other questions? No? Cool. Well, thank you. This is where you can contact me.